Chapter 8, Section 7. So now we are getting into factoring some special cases. So we've done factoring with a couple of different polynomials and or trinomials, I should say. And now we're going to show you some tricks on factoring when we have perfect square trinomials. And what we're talking about is we're basically reversing this. So if you remember these special cases, when we had a plus b squared or a minus b squared, it turned into this. Now what we're going to do is go from this back that way. Okay? So the first step is identifying whether or not it's a perfect square trinomial. And to do that, what you're looking for is the a and the b part, are those perfect squares? And what we mean by perfect squares, do they have square roots that become whole numbers? Okay, or their whole square roots. So like a squared can be, the square root of a squared is just a, the square root of b squared is just b. So this could be like a squared, or this could be the number 9. Well, the square root of 9 is 3 squared. And so that's the kind of stuff that we're looking for. So if it is like this in either of these forms, these are your answers. So again, just backwards. Okay. So let me show you what that looks like. Here we have x squared plus 16. We know that 16, the square root of 16 is 4. And this middle term then becomes 4 times x times 2. 2 times, in this case, x times 4. And so those would split up to that, which become x plus 4 squared. Okay. Same down here, 2n squared. Its square root is 2n, and 9 square root is 3. And if you take those two, if you take 2n times 3, you get 6n, and you take that times 2, you will get negative 12n. So let's look at this. What should you do with something like this? Well, first off, try to identify, is that a perfect square? So is the square root of x squared, what is that? Well, it's just x. So the square root of x squared is x. And the square root of 36 is 6. Okay? So they both have, they're both perfect squares. Now, if we combine those two, 6 and x, we get 6x. And if we take that times 2, do we get 12? We do. We don't get negative 12, but all that means is that we just got to make this a negative 6 times x times 2, and that'll give us negative 12. And so what this becomes is, it is x squared minus 2 times x times 6 plus 6 squared. That's how we could break this up. And again, where I got that from is, remember this, x squared minus 2 times ab plus b squared. I identified what was a, which was x, and what was b, which was 6, and plug them in. And if that works, all you got to do is write your answer as a, which in this case is x, minus b, which in this case is 6, squared. Okay, let's try another one. Square root of x squared is x. Square root of 9 is 3. Can we write that where we have x squared plus 2 times x times 3 plus 3 squared? Can we write it like that, and does it equal that? X squared, that lines up. 2 times x times 3. 2 times 3 is 6. 6 times x is 6x, so that works. And 3 squared is 9, so that works. So therefore, we just have x plus 3 squared. Okay, try this one. Square root of x squared is x. Square root of 49 is 7. If we write that x squared plus 2 times 7 times x, oops, should be x. Let's redo that. Should be x squared plus 2 times x times 7 plus 7 squared. So what I did wrong is I didn't make this a minus sign, but let's say I didn't know to do that right away. Okay, is 2 times 7 14? 14 times x, is that negative 14x? No, it's not. So what that tells me is I messed up. The only way that that works is if this was a negative 7. So the square root of 49 could be 7, but it could also be negative 7. So that's what tells me that this has to be a negative 7. And therefore that's x squared plus 2 times x times negative 7. That becomes negative 14. And this becomes negative 7 as well. But negative 7 squared is still 49, so it still works. And our answer is just x, which is a. And then it's, minus 7 squared. Okay? The other special case is when we had something like a squared minus b squared, and you remember the backwards version was a plus b times a minus b became a squared minus b squared. This is a little bit easier to identify. So if you just have a binomial and they're both perfect squares, you just split them up as a plus b and a minus b. So let's try this one. What is a in this case? The square root of z squared is z. And the square root of 9 is 3. So since it's a squared minus b squared, it just becomes z plus 3 times z minus 3. Oops. Okay. Let's try one of these. So again, we have a squared minus b squared. Again, the toughest thing is identifying this. So it's a squared minus b squared. Is this a perfect square? And 100 is, right? The square root of v squared is v, and the square root of 100 is 10. So because it's in the form of a squared minus b squared, oops, sorry. This should just be v, and this should be 10. Because it's in the form of a squared minus b squared, we can just write it as v plus 10 and v minus 10. Here, again, we have two perfect squares. The square root of s squared is s. The square root of 16 is 4. S plus 4. Sorry about that. And s minus 4. This should not be in there. There you go. And those are the special cases. These take a little bit of practice. We're going to try some more in class and our assignment. But make sure that you review this. Again, what we're looking for is perfect squares. So a good thing to kind of get memorized is, what are my perfect squares? Perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So it's like 1, 4, 9, 16, 25, 36, and so on.